How's it going? I'm Jason with Arize AI. We do observability and evaluation. We're one of the leaders in this vertical. I think we probably, as a leader in kind of observability and evaluation, I do think we've probably seen more AI in production than most other companies. This is kind of what we do, bread and butter all day. And with that, we've also have our own assistant, our own co-pilot, our own kind of AI integrated in product. So tons of experience is what I'm going to talk to you about through customers that range from TripAdvisor to Priceline to bookings, top ML teams in the world, top enterprises in the world use our software. This is starting at the highest level. This is, I would say, the year of agents. There's an incredible set of frameworks that have come out. So there's people, I would say most people actually are, if you look in the last 12 months, started without frameworks. So you don't need a framework to build an agent, first off. And maybe that's not the first thing to jump to, but there's a lot of frameworks now. So LangChain has LangGraph, obviously. Llama Index has workflows now. You've got Crew, you've got, I'd be remiss to not mention AutoGen from Microsoft. So a lot of frameworks to help you build these, but most of what I see in production actually is not a framework. On the right side, what's powering this really, if I would, the most basic feature within the models is function calling. So the ubiquitousness of function calling now across the LLMs is really powering what I would say most of these agents look like. I'm going to start off with what I see in production, and this is really, you're going to see really complicated, framework diagrams, but really most customers I see today are doing something pretty simple. They have what's called an LLM router. A quick survey of the room. How many of you have heard of LLM, the LLM routing function, LLM routers? Okay. Okay, so decent number. So what the router does is it actually helps route, looks at like the intent of the conversation and helps it route to the right skill or task. It uses typically function calling from a model, but I've seen actually more complicated versions from some of our customers that kind of build their own function calling into it. So either way, you're trying to route to a skill, and that skill, when I say function calling, doesn't necessarily need to just be a call to code. Many customers actually have a routing of a skill to maybe another LLM call. So you can have a set of LLM calls that actually do something in your flow, and then you typically route back to the router. So it's this iterative flow that goes from router to some amount of branching skill to back to the router. Now, this is maybe the simplest form of an agent, simplest form of an assistant. There's routing, and there's some processing of branching. And when you say, well, what is an agent? You'll get all these fancy terms. Really what it is you have an LLM here making some intent decision, and then some processing in its simplest branch form. Now, you can get much more complicated than this, but this is probably 90% of what I see deployed today. It looks something like this. An assistant has maybe a router, a skill, and then you go back to the input again. Router, skill, back to input. This is like 90% of what I see. Now you can get much more complicated. What happens inside that skill? You can do 3 LLM calls. You can do complicated platform and API calls. You can do a lot there, but this is probably what I see most of. And so first note is don't get lost in all those big LangGraph kind of node drawings. This is working for a lot of people. Super simple. And then some of these there's some of these examples, as you get more complicated, actually have some state. So maybe I have a skill that processes data or does AI search across data, and then I'm saving that state off, those results, and then some other skill down the way might use those results. So there's typically some state or memory used that spans these stages. So this is kind of the most basic form of assistant or agents that I'm seeing out there. The point of this is there's I was kind of hinted at before. There's kind of state that kind of feeds these skills, and so I've seen some examples where a skill such as AI search might use up the entire context memory. And so there's some small result that you want to save off that some other thing wants to use down the way. You can't just save off the entire set of calls in message bus. So state ends up being important. And then as you look at this, as you start to create these agents and you start to create these assistants, it's with a couple lines of code in any of these frameworks, or even whatever you're building yourself, you can get an incredible number of distributed system calls. So there's single lines of code, I've seen like 50 distributed system calls in some of these frameworks. So it's just, there's a lot going on under the hood. The good news is most of these frameworks, if you're using a framework, have tracing callback systems that platforms like Arize or our open source Phoenix plug into. So tracing is part of lane graph, is part of workflows. And so debugging these systems ends up being like, okay, let's collect the data first. What in the world did I call? Why did it make this call? I got to collect the data first to even understand it, which is what tracing does. How many of you have used like tracing in any of just general LM applications? Okay, wow, that's not as many as I thought. I think I would say it's really hard to debug most of these. You can start with Phoenix, which is free, and one line of code in any of these frameworks. You can get tracing. I'll show you it in the end, but definitely pick it up. It's like the open source version of Langsmith. The example. So what does this look like? I'm going to go deeper into like what a real use case is, and we see this a lot, and we've seen a couple of these examples in e-commerce, which is like a chat to purchase assistant, where I'm going to kind of extract either trip planning information or what products you want out of your conversation, and then I'm going to like I'm going to allow you to either look up a product or get you information back on a product. And typically these are, maybe the end goal is to get you to purchase something at the end, but this is a typical assistant thing. So there's a LM router in the beginning. It's trying to figure out if you're doing search or question and answer about products, and then there's some LLM afterwards that's actually taking action on that. So LM in the beginning, routing you by function calling to a skill. In this case, the skill could be searching an item, or it could be a Q&A. And then an LLM's processing that data and returning back to the router. So this is kind of what it looks like zoomed in. What it really looks like might look like something like this, which is, there's a bunch of processing stages. But again, it's that simple branch, LM router and branch architecture. It's, again, a great place to start. You can get more complicated from this, but you can accomplish an incredible amount with just this simple router branch. And you notice some of those branches actually have LLM calls, which are the yellow triangles, and some of them are just pure code. I might just be pulling information from the system. So so in my branch, when I decide to go do something from an assistant or agent perspective, I'm processing something. It might include an LLM in there, or it might not. I might just be doing, say, product lookup and feed that back to the original router. So kind of have to talk about, if we're going to talk about evaluating agents, I've got to talk about what this looks like in the first place and what problems can go on. Some of the common issues with this are did I take the right branch? And normally when I'm going on a certain branch, like it's an intent, did the person ask for a product information on search, and I sent them a different direction. And then part of the branch includes like parameter extraction. So function calling includes what intent, what direction, as well as the parameters to go on that branch. How many of you know what parameter extraction is, or have used function calling? Okay, it's a smaller amount. But so with function calling within the LM router, you're determining what direction to go, and you're providing some data to the branch. And that's where that can go wrong. I would say the most common thing that we see, at least in the router stage, that goes wrong is the extraction, parameter extraction. Am I extracting the right data? Is it in the right format? Is it just off in formatting? So there's kind of that piece, and then you're kind of broken if you haven't extracted it correctly. And then sometimes there's just, did it get the intent right? Did it go the right branch? want to kind of also view the other, I want to talk about the other piece in the ecosystem. There's these frameworks that have come out. So Llama Index Workflows is one, LangGraph is another. And I view like LangGraph as like, you had chains originally and now you want loops, so let's create a graph. So like LangGraph is a natural extension of LangChain. It allows you to do iterative things, flow control using LLMs. Nodes and edges is how you see the world. Llama Index Workflows is a competitor to that. It's kind of event-based. You can argue, our team did basically an agent in both of those 3 versions and code recently, comparing it. I think it's on a part of my co-founder's Twitter. And the takeaway is like there's pluses and negatives to each one of these. It's kind of, do you want to think of the world in terms of nodes and graphs? Do you want to build this way? Again, most of just putting out there, most of what I see currently is actually code, not these. So new frameworks, we'll see how much they make it easier or harder or get in the way. So again, I feel like it's this big story of last year. It's really easy to do a Twitter demo. It's hard to make this stuff work. So working for your demo is not just making it, is performing well, is really the big challenge. So what we'll talk about a little bit is kind of how do you go from like working to actually doing well. So how do we evaluate these agents? The first thing you have to do is you really do need to collect data. Like you can't take an action, you can't do anything without collecting data. So you need to instrument it. You can instrument it. In our case, what we do for Phoenix and Arize is we use OpenTelemetry for instrumentation. It's a standard. It's a way of instrumenting that most people, you can chat instrumentation around it. It's pretty easy to figure out. And then with us, you're not locked into a framework. So for us, it's open, or we believe in kind of an open ecosystem. But you got to get your data out of these frameworks if you're using them, or if you're building in code, you've got to instrument that and get some visibility into that. There's testing, so like you'll get this data and you'll try to understand like where am I breaking. So you'll want to build up tests around, did it make the right path, the routing path, is the skill correct and the results from the skill correct, or task correct, or the branch, whatever you want to name that thing. And so there's really kind of 2 evals that we seem to care about, is the routing right, is the skill or task action right, and then whatever breakouts occur there. There's typically you're creating evaluators. Those evaluators can be LM as a judge or code-based evals, depending upon what you're doing in those steps. And then it's about kind of experimenting and iterating. So this is kind of like the big picture, and we'll show you a little bit around what this looks like. A quick question here: does when I say LM as a judge, evaluators, do most people kind of know that? Yeah, okay. 12 months ago that wasn't the case. Now everyone's singing the praises. So when I say kind of am I using the right skill, so there's, again, a routing phase. There's at some spot, and you could have multiple spots, like in our assistant, we actually have multiple routers. But at a routing stage, you're just trying to know, am I taking the right branch? And am I extracting the right parameters? So from an eval perspective, as you're thinking about your agent, is it making the right control decision? Is it going the right direction? Is it extracting the right data? So these are kind of the biggest idea of kind of, is the LLM router stage doing the right thing? And then we also do this component on our side around understanding whether it's converging. So this is if you have multi-step and you're iterating in some way or shape without input flows. I would say less people are probably letting it be open loop these days. Most people have some user input in the middle. But if you have some task or something you're trying to do, there's possibly a convergence component to it. Some assistants don't have this. Some do, depending upon if you're iterating. So what does an eval look like? An eval typically looks something like this, which is, and this is an LM as a judge eval. There's also code-based evals. LM as a judge eval will have some information that's contained in a template, and then some components that you're pulling from to test. I'll give you an example of this. So what we have is we have Phoenix, which is our open source offering. You can start it, get on it today. Again, it's like open source Langsmith. And then we've got Arize, which is our enterprise offering, which has quite a bit more than Phoenix. It's AI enabled in a big way. So what I'm going to show you today, though, is Phoenix, which is a kind of the shorter, small featured, but smaller feature sets. But you can start on it and use it today. What typically you do is you're instrumenting your code, a couple lines of code here. You're instrumenting with Phoenix. Phoenix then collects the traces, and you can run evals on top of them. In this case, you've got an agent, kind of each loop here. I've got evals on this particular one, so function calling and parameter extraction are the two evals. In this case, I've kind of have explanations around what the problem is. The user's question was about promotions, and you've kind of gone down a search path. So the question was about trying to get information on promotions, but I've got search path. What typically you'll want to do is when there's a problem, you'll build data sets. You'll save off hallucinations or problems similar to your typical LLM application work. Those data sets tend to be what you want to test against. So you end up with experiments being what you run tests against, and experiments can be testing on different models, testing on different template versions. Experiments are typically things that you want to eval themselves, so you're saving off data. In this case, I'm checking about the parameter extraction and the function calling for a bunch of cases where I'm getting it wrong. I'm trying to change my router template to maybe fix that and make sure, with these additional instructions, shape it and form it the right way from an intent perspective. And so it gives you an idea of kind of how you run, how you test, and at least this is the LM router stage of basically understanding performance and saving off to an experiment and then rerunning experiments for them. From a Phoenix perspective, if you want to start, Phoenix is free, open source, easy to get started. Option, please, our team lives on stars, so if you do use this, please star us. And then I did want to kind of open it up to some questions from the room around agents, evals, frameworks, any of the the topics that you might want to ask.
Could you define what a skill is?
Define what?
A skill.
A skill. Yeah. So in an assistant, and I would say it fits into maybe the assistant view, which is normally there's a user input. You're normally routing to something that this assistant can do. Sometimes the assistant example might be able to generate a SQL query and query a database. Or the assistant might be, in our case, our assistant can help you write an eval. Or our assistant can actually do AI search. Our assistant actually can also help you create a graph and a dashboard. So the assistant's kind of routing to a skill. The skill then becomes go accomplish this task. And so a skill is just a branch in this kind of tree, really simple branching architecture of an agent.
So like how does LLM play in the eval? Is that like it generates the evaluation and you manually tag it right or wrong, or like you leverage LLM in the Phoenix platform somewhere?
Yeah. So the questions around evals and how does it integrate into these platforms. So evals, as I mentioned, fit into two categories. They're either like Python code, which is really, think of it just a test case, or an LM as a judge eval, which is LM running on data. Both of those can be run offline, so think of it in Python running, you run it in your test environment, maybe GitHub Action runs, you run it. It can also be run in our platform, so the Arize AI Enterprise supports like online evals, which is a term meaning LLMs run on your data as your data is ingested, augmenting that data with kind of, think of it as labels or evaluation results. So most, I would say there's a handful of platforms right now that support online evals. We're one of them, and I would say everyone who's doing this, I use those all the time, every day.
Yeah,
Yeah.
So the open source, does it still offer an online eval, or is it we have to go to the platform? I'm basically asking who runs eval on the open source?
Yeah, so on the open source right now, it is the user, you put in your key, you run eval, you run eval as you kind of ingest data. So it's going to be on you who runs the eval versus our enterprise offering, we're kind of running the eval.
So it's
Yeah.
an offline process where you pull the data in?
Yeah, correct. Yeah.
Yeah, so I have a question. So usually LMS Church behind the scene is a evaluation model.
Yep.
So how can we make consistent about the evaluation results? Because as I know that it may be not very consistent and sometimes may involve the human eval. So how do you incorporate this process, or how do you resolve this problem?
Yeah, I mean, good question. So it's a deeper question about evals. So the question is around how do you choose an eval model, and then how do you incorporate kind of human feedback, and how do you think about results? So if you look at Phoenix, the open source library, we have a bunch of tests for the templates against handcrafted data sets and a large set of models. So we kind of give you our recommendations. I would say most of the modern models, even the minis, are doing pretty good these days on the eval test sets. So I think last year choosing an eval model was harder. This year it's more about speed and scale. And so my other note would be a lot of these providers have generated these SLMs. So think of it as GPT-4 Mini or Gemma, and they're designed really for guardrails or eval, like more scale, for like larger scale cost. So most teams are deciding, okay, do I want the flexibility of a GPT-4o Mini or Gemma and just do and just iterate on prompts with it in those? Do I want to kind of just use my large model? Any of those are supported by us. We just kind of give you recommendations based upon test sets. And then some teams are trying to go the route of fine-tuning an eval model. I've seen that direction as well. I think the problem with that one is only go there if you're like really at scale and it's hallucinations and maybe it's not going to change, or I only need to do it in English. I don't need to do it in 500 languages. Like there's risks of that direction. But I think it's working for a group, and so eval fine-tuning a model is also direction. The last point is human annotation. I don't think LM as a judge gets you away from human annotation. You got to have that. You need those. And the last point I would put is all our evals have explanations, which gives you, I don't think you can get evals right without explanations. I really don't. I think we end up using them all the time to adjust the eval prompt, because you realize, okay, it said this is a bug, but it's really just missing import statements, which I don't think it's a bug in code. So you add stuff to the eval to make it as strong or to give it the direction you want. So that's what I would say. Human evals, choose a model. Most of the minis are great these days. And then don't forget human annotation.
So
Do these eval functions, like on the big mapping that you showed,
Yeah.
kind of here's the step-by-step process. The eval functions, they tend to be pass-fail functions, like link assertions, or are they more a natural language reply that gives a human being some guidance on what happens?
So the evals tend to be like pass-fail. So the evals itself tend to be like categorical, and it could be you don't need like just pass or fail. You can have a 1, 2, 3, 4, 5. But typically, what I would recommend not doing, and what I saw people doing last year, was trying to get continuous ranges. So most of the stuff we see is categorical, small set of categories of ranges, well defined, and it's just getting you this pass fail, but then you get an explanation with it,
Pass-fail is one.
yeah.
So for the agents that these tools are calling,
Yeah.
what is the abstraction that you should have? For example, one can imagine that you might have a web search, and
Yeah.
you specifically say, I want Google search to be used. But what if I just decide, okay, I want web search, and the tool should decide which one to use, like Bing or Google or DuckDuckGo or whatever. So
Yep.
at what layer should you handle that evaluation? Should you evaluate that on the agent layer, or should there be some kind of tool optimization?
Yeah, I mean, I think from an agent evaluation, it's kind of a fancy term, but really what it means is you're trying to break up evals across your system to make sure it's doing the right thing. And normally what that means is it's not just one eval set. It's like I'm maybe doing an evaluation for whatever routing control flow I'm doing to make sure the control flow and extraction's correct. I'm doing an evaluation of the branch, whatever branch it took, to make sure the results are correct if there's LLMs there. So when we say evaluations, we really mean breaking the system up and doing an eval for the components that are doing. And your example case, I think it just comes down to, is that something that's integrated into the routing and you want it to happen there? Is it something that you want it to happen in a branch of the control flow? So I think it's about you mapping out your system control and then figuring out where you want that control to be or flexibility to be. And then the evaluations just make sure it's doing the right thing on top.
How do you differentiate different kinds of models and LLMs being used in different stages of this process?
Yeah.
You mentioned an evaluation explanation text.
Yeah.
Right? That's coming from an LLM, I presume, right?
Yeah.
So how do you differentiate that from the production model that's being used? Do you stamp them as different models? Do you use the same model everywhere? Do you say that for the skill, I don't care what model because it's a small task? How do you differentiate?
Yeah, I think what we've seen work well. I mean, I think you can get it. So the question here was like, how do we see the decisions that people should make or are making around what model to use for evals versus production? I think what I see as kind of easiest from most teams is like starting with, if you can, starting with the larger models and then backing down once things are working. I feel like people backing in the other way, you don't realize how hard it is just to get the stuff to work in the first place. So I think that's kind of what my recommendation kind of is. Yeah.
The distinction was around when I'm doing,
Yeah.
when I'm building an application, I
Yep.
have the application somewhere elsewhere and all calls are happening.
Yep.
When I'm doing an eval,
Yep.
there are certain calls happening just from the eval.
Correct. Correct.
Right? So when you are generating the text for the eval, that's the platform.
Correct.
That platform will
Correct.
be somebody else stamping it, the builder of the eval platform stamping that LLM call.
Correct.
As gold quality.
Correct. Correct.
And then use. Like
Yeah.
it's building layers and layers of gold quality LLMs.
Correct. Correct. So you're augmenting your data with data that helps you understand its performance. So that's correct. And you can choose different models. You know, I think a lot of people just start off with the same eval model as the other one and then back out into something else that's working. Go ahead.
When is
Yeah.
this eval done? Is it done before I deploy the system, or is it done during runtime as a test?
Yeah, it's both actually. So Phoenix actually has a bunch of little helper functions for evals and code. So if you just want to run in your notebook and test, and those same functions actually work really well in like GitHub Actions. So if you want to go from there to CI/CD, and then if you want to just run an eval as data flows into our platform, you set up a eval job, and it just can take a sample of the data based on filters. We'll drop evals onto data as you ingest.
Do people
Yeah.
use this to deploy a new version of the system where you have new, better prompts, for example? You get different data, you need to refine the prompts
Yep.
for another release. Can it be used that way as well?
It can. So I would say I'll show you. I'll talk to you about our Copilot within our assistant. What we use these for. So a real use case from what we do. The online evals tend to be like, I just want to drop data on I just want to learn something new. And so an example was we had some prompt injection attacks, kind of like people were trying to kind of hack our system. And I just wanted to kind of add an eval quickly to see, to detect if anything similar to this was happening. So I just wanted to kind of monitor it, and I can add, and so that was kind of a prompt injection eval. I've also added stuff around frustrated users. So it's kind of like I'm just adding performance data that I want to go track. In the case of the CI/CD stuff, which typically is called experiments, I don't love the word, to be honest, but all of us, all the platforms have landed on experiments, including us. So in experiments in our platform, it's the CI/CD portion of the workflow. So for experiments, you're saving off data sets. You're typically running the test in like a GitHub action or offline, but it's in our customer system that are running these. A lot of times it's code, like, is the location right? It's just Python code. And then sometimes it's an LM eval that they run too. So that's like this, and that one normally is like, let me make sure I didn't break anything with this new prompt. I make a change. I just want to make sure these 10 use cases pass. So it kind of helps you with your development-driven workflow. So experiments kind of help you with that. Yeah.
I was wondering, I really like how you break it down into
Yeah.
individual bite-sized evals. Do you also do longer trajectory, multi-step, and like how do you think about
Yeah.
when you push it?
Yeah, it's a good question. So like when do you obviously kind of span level evals are, I think, easier to think about and apply. But there are some examples. The really common one from the customers is like a conversation level eval, and did the person get the question answered, and are they frustrated? So we have some examples of session level evals, but they're just harder to they're harder to run in that you need to collect the data. You need to collect that data, and then if we're running a job, it's got to smartly connect what is a session and run the eval in the session.
Thank you.
Go ahead.
So I just have a question regarding the evaluation framework, of course.
Yeah.
So say, for example, I don't want to use model as a judge, but
Yeah.
instead I want to use my own benchmark data set, which consists of prompt and the root
Yep.
and the answer. Can I do that with Phoenix? I just want to see
Yeah.
how flexible it is if I can use a benchmark data set and on top of that, some human evaluation setting out there.
Yeah. We try to make it flexible so you can post whatever. Don't need to use our eval sets or eval recommendations. Just post post whatever scores that you want into the software, and post your checks. And we try to make it easy to find whether the check's passed or not.
Okay. Thank you.
Go ahead.
Evaluations are assuming that ground truth is high fidelity, that it's golden, it's correct.
Yeah.
But in real systems, we do see that ground truth can change. Like
Yep.
in RAG systems, new document version comes up, new information comes up, which means the golden answer is now changed.
Yep.
In Phoenix or in Arize, do you have a way to identify that if the ingested document has changed, then possibly it has affected a particular answer for which it was providing the golden ground truth,
Yeah.
and help the user say, hey, because of this new document you ingested, this ground truth or these ground truths got affected, re-verify them.
Yeah.
Is there something like that?
Yeah, I don't. So typically we the question's really around ground truth evals and production, and I would say most of the people that are using evals in production are using it as like a proxy, like it's like a gut check of, is the system working correctly, and so typically you're running, you don't totally like have ground truth like a traditional ML model you would have. You're kind of using it as a proxy, where the ground truth was just to make sure your eval was correct in the first place. There are a lot of tools though to understand whether the data's changed, and the reference data's changed, and also to debug whether the eval is correct or not. So I would say there's a bunch of tools, but not exactly what you're asking there.
Because consider the non-deterministic of the LLM, so you cannot actually provide all the test sets for the follow-up questions.
Yeah.
How do you actually deal with this challenge?
So the question there is sorry, so test set for the follow-up questions. So can you describe that again? Like are you talking about?
Evaluate like a conversational.
Yeah, I mean evals. You need the data present to say whether the eval is going to be, the eval can only look at all the data it has and make a call on it. And if you don't have the data available for it to make a correct call, it's probably not the right proxy metric. It's probably not the right place to use it. And so it's your job to kind of like figure out what's the right data to put in the first place to be able to make this performance metric and make it correct. And if you can get that data there, then you can actually do an eval for it. So I think there's production data that looks like that, and then the CI/CD workflows tend to be more golden data set, human annotation, you're kind of you're doing that, and you're making adjustments to the evals based upon your golden truth from human.
The problem is that you can have the best test set, but then the consistency
Yeah.
of the evaluation is the problem. Because the next time that you run the evaluation, you may not get the same result based on the different questions.
Yep. Well, I think so there is variability in these. These aren't kind of these are kind of proxy performance metrics. So I think again it comes down to like how exacting or do you want how important is your performance metric? How exacting do you want the result? I think what you're hinting at is like I run it multiple times over a test set, I get different answers. It's just a proxy metric. So that's what in the end I think view it as such, and it gives you a good direction. But well, thank you all. Appreciate it.